Hello everyone, myself Dr. P. L. Kumar, presently working at NIT Manipur as an associate professor in the Department of Civil Engineering, myself also the Dean Academics and Affairs of the institutes. Taking this opportunity of this Northeast Science Movement today, I'm going to present a few of our research work and the implementation into the field work by a topic called the optimization of the indigenous techniques for low-cost water treatment plant. So, to begin with, all of us knows that it is not that our forefathers, our old generations, are not that educated. Even though they were not literate, I'll say that they are much advanced than even some of the present modern human beings. They have developed many technologies without knowing the root of the actual work. And today I am going to use some of the indigenous techniques that has been used by our forefathers, enhanced it, optimized it, and we are going to use it for a low cost water treatment in a very big scale. So, to begin with, most of us knows that there is a water crisis everywhere throughout the globe. The water crisis can be, say, defined in two ways, precisely. The first one is when there is no water available at all, say for example the deserts, fine, or the place where there is completely contaminated or polluted rivers. However, there are a lot of water available, but the thing is, the water demand is more than the water available. That itself is also another water crisis situation. So, as per the Niti Aayog report, more than 2 lakh Indians die every year due to the non-access to the clean water, a lot of health affecting issue. So today we are going to start with what is the actual things that is faced by the villagers, even though many of us have come across in real life. To make it precise, we see that the water crisis has been especially due to the increase in the water demand, especially I'm trying to explain for the rural areas. Because in urban itself, commercial or some other way, always it is available, maybe at a cost. And another one is altered weather patterns. Then the lack of proper treatment facilities. This is very much important. In many towns and the cities, there may not be no space, but still the proper water treatment plan is there, even though the efficiency may be not high. And in the rural area itself, the construction of the low and the large cost water treatment plant is not very economical because the population also is not very high. So what we come across is always the villages depends on the commercial water or sometimes in the pond river itself. And sometimes due to the over exploitation of the pond itself, the recharging capacity of the pond decreases and hence even the pond becomes dead, right? Plus the pollution of the ponds and the rivers in the villages itself, maybe to the kettles and the cows, the buffaloes, they're taking bath, and even due to improper sanitations like washing, drinking, bathing, cleaning everything in the pond itself. So these are some of the issues that we've come across. So in view of that, we're trying to identify some of the indigenous techniques done by our forefathers, and we're going to enhance it. We know that if impurity is there, it has to be filtered out, just like the filtration of the tea leaves while making preparation of the chai and the coffee. So they use a lot of charcoals, they use a lot of scent particles, even though they may not be knowing what is better, what is the mechanism going on inside in the science of physics, right? So these techniques of filtration by the sand, iron, then the what you call this filter water through, say iron chips, coarse sand, wood particles. These things we are trying to see the mechanism inside through the available resource, and we are trying to do in a very large scale. Okay. So now most of us knows that the sand filter itself is the most common technology applied everywhere for the treatment of the water. That is, we call it the biosand filter. The mechanism itself has been implied for using of slow sand filter for treatment of supply in many urban areas throughout the country, throughout the world. So here, the main mechanism that lies is not only the filtration by the scent process itself, but there's also a provision called the biofilm that is developed on top of the bioscent filter. See, for example, on the top of the bioscent filter, there is a layer that develops automatically that takes around 10 to 15 days. We call it dirty skin layer, or we call it the smooth jack layer. So this layer itself contains a lot of microorganisms that fits into the incoming pathogenic bacteria that are quite giving a big contamination to our system of the body. And plus, it also fed into the small nutrients like the iron, maybe phosphate, nitrate, which are some of the common ingredients in the pond water, right? So to make it quite big things, what we do is, the mechanism that we define is, number one, in this bioscent filter itself, number one is the mechanical trapping. Why we are trying to identify the mechanism so that we can multiply it using the science, technology, concept, and we can design a big scale. The mechanical trapping is nothing. It is a trapping of the finer solids between the space and the voids that lies between the scent particle. So when we try to design it, we design it in such a way that the size of the scent particle itself we are going to optimize. Okay. Then, as I explained before, the predation of the pathogens by the other microorganism in the biofilm. So most of the pathogens are eaten by the microbes and they develop the layer by themselves, which has to be maintained consistently. Once it is dead, the prolapse or the collapse of the biofilm is there, then it takes another 15 days, which is going to decrease the efficiency of the plant. So sometimes we have to maintain some standing water on top of this filter bed so that at least the longevity of the biofilm can be attained. Plus another problem is when we fed into the reactors, the water we put by splashing, maybe by container, we pour it out. That itself is going to kill that itself is going to destroy the thin permeable membrane, the biofilm, which also acts as a filtration medium through its semi-permeable membrane by trapping the ions. So we have to add some diffuser, that is simply to decrease the discharge of the flow towards the filter. Fine. So now, coming to my project work, what we have done is, in the state of Manipur itself, we have constructed a low-cost water treatment plant that I'll justify in the later presentation. And moreover, we also got some project from Nectar, that is Northeast Council of Technical and Rich. There is a branch of the DST for the construction of this plant. So, firstly, we surveyed and tried to identify the place where water are quite contaminated, plus the place where water is available throughout. Say, for example, after constructing the water treatment plant, if the water is not available there itself throughout the year, then the plant will collapse. And the next maintenance in the next year, it's going to be an issue again, who is going to fit the cost. You can see the villagers, the woman with my two lady staff over here, my team members. See, these peoples, they are completely deprived of the rights to drink pure, fresh, good water throughout their life. Along with their forefather generation, they have never come across what is pure water, which we the urban peoples have the facility or the advantage of, even though maybe through cost. So after several surveys, the health effect, the issues, the nearby pond, we identified it. And then what we came across is that the villagers, they depend mostly on the water and the local ponds. They're also without further treatment. They treat it by using indigenous technique. But the thing is, how much the water is pure. The thing is, it may not be an acute effect. That is, it may not give an immediate effect. But in the long run, say for example, due to the excess of fluoride or due to excess of iron itself, in the long run, the mottling of the teeth and the skin lessening, the colorful skin, all this thing comes. That will be the chronic effect. So, turbidity water with a suspended particle are also quite common. The rivers are not perennial, the skin disease. And another issue that what I came across is, it is not that the villagers doesn't have any water treatment plant. They have a very decentralized water treatment based on the slow scent filters. by using the coagulant like alum to remove the turbidity and chlorine for disinfection purposes, right? For all this water supply scheme. But what happened is, for a sand filter to work, the development of this this biofilm, we call it smooth egg layer, is very important. So what happened is, they didn't run the plant continuously, unlike the urban water treatment plant. Once the plant doesn't run continuously, the food of the microbes to maintain the biofilms, that's going to remove 98 to 99% of the pathogens, the biological parameters, that's going to get impacted. So what happened is, after 3 days they run the plant, after 4 days they run the plant. Sometimes due to the lack of the fund to run the water treatment plant, they stop for 10 days. But once it recovers, they start running the pump. The next day itself, the villagers will get a water, but the water will have very less treatment against contamination, even though they use chlorine. And we don't know how much chlorine they used most of the time. Again, if the chlorination is quite excessive, a lot of chemical residues are there on the containers wall of the containers what we used, right? So we are trying to make a plan in such a way that this type of chemical consumption like alum is going to be minimized, because the sludge that is going to come out of this water treatment plant itself is going to contain the alum itself, the aluminium, and hence it also sometimes affect the ground porosity, the ground reproductivity for the crops. Okay, so taking all these things, what we do is, I'm going to come to the project work, what I want to share with my fellow members who are listening to this program. We designed a reactor in such a way that first of all, it consists of roughing sand filters. The roughing sand filter is important because why we are using chemical coagulants like alum, ferric chloride, the reason is to remove the turbidity. So if the pond water is having high turbidity, we try to completely not look upon that pond, but however to find another pond with less turbidity. However, for a turbidity of around 10 to 15 nephelometric turbidity unit, it can be reduced below 10 by using these roughing filters. That's going to make by small pebbles of around say 0.5 to 1 mm of the broken chips, right? It's not going to remove everything, but just to reduce the turbidity, so that when it's going to fit into the feeder tank, the next reactor, it's going to be the removal of this less diluted turbidity along with the nutrients, with the formation of the biofilms, and going to remove the pathogens. Fine. Then finally, after the reactor, it comes to the collection. Okay. So this is the front view and this is the side view. So it is going to be simple basic concept of the gravels laid at the bottom to collect the water, supported, and then the sand bed of around minimum 1 meter depth. So the depth of the sand bed is also we evaluated. The reason is, if the thickness of the sand bed is not very high, then escape or incomplete filtration do occurs. And the height of the water also do we maintain for around not less than 1 meter. And the reason we make it 1 meter is because if the water level is very less, the discharge that's going to be done by pumping itself, by feeding into this reactor, it's going to destroy the biofilms, which is going to be very important for treating the ions as well as the contaminant, the pathogens, by these active microorganisms. Fine. So see, and on the right side you can see we have on the top view we have 8 reactors. It's a single reactor, say around 6.2 meters by 3.2 meters, but rather we make it into small fractions. This is from our research experience, from our project experience, that in order to maintain the biofilm, if the diameter is quite huge, then the collapsing of this semi-permeable membrane biofilm smooth egg layer is quite very high. The risk is very high. We have to minimize it. So what we do is that we decrease the diameter. But decreasing too much diameter, small diameter, again, it's going to impact in cleaning and maintenance of the reactor. Fine. However, it do advantage that if one reactor fails, the remaining reactors still can function it. So this is one advantage. Okay, so this reactors cross section will make it around 1.25 meters to around 1.5 meters, segregating by the walls. But at the bottom, they are connected by the pipes so that water can be collected completely together. Okay, so how it looks like from the top, you can see the photographs that already we have done the completed two project. These are the segregations we have done on the top of the reactors. So different, and you can see the blue pipe over here. The blue pipe is nothing, it is the feeding pipe itself. And what we do is, in order to minimize the prolapse of the reactors, we have to add something called diffuser, something like a sprinkler, so that the velocity will be decreased. So to make it more minimized, what we do is, we just punch small holes into this pipe itself, some like perforations, and then it sprinklers on all the sides, hence try to give a minimized impact on the biofilms. And it's covered by this jali net and along with the roof. It is not in a textbook, but trying to prevent from all the rodents, the birds dropping, which may contain some virus sometimes. So we have to prevent these things. Fine. So this on the left side, you can have a look. It is 4 vertical reactors. On the right side, you have 2 reactors. So one is the front view, one is a side view. So this 2 into 4 is going to give the 8 reactors. Okay. So you can see that at the bottom itself, there are 4 holes. These are the outlet pipes. And on the cross section, there is a slope provided so that at the bottom there is a tiny hole so that the water can be collected with the slope, and then the outlet will be completely collected only from one side of the reactor to minimize the cost. Okay, so how it looks like in the real life, that is going to be like this. Okay, see, you can see that there are 4 pipes, the 4 green pipes, and then on the top, it is not that the water is coming from the top and going to the bottom. From the bottom part, the water is collected and it's coming up. It's coming up from all the 4 reactors and it's collected with the slope towards the reservoir. So there is only treatment for removal of turbidity and then the biosand filter. Okay, so over here, what happened is, as I mentioned before, you can see that the top of the sand layer, always we have to maintain a minimum depth of 5 to 10 centimeter. But this water treatment plant, this is not going to be continuous. It's low cost. The villages are not going to depend by 24 hours. It is going to run at least once in every 48 hours or 50 hours. Maybe once in every 2 days, alternate days. Correct. So to maintain the lives of this biofilm, at least we have to maintain for some particular depth so that even without a food or with the available limited number of food, they can sustain or survive for another 48 to 50 hours. Right? So some water is maintained. How we maintain it? You can see that the outlet is there and then it is going out by raising the hydraulic head. So see, these pipes that I told you, these green pipes, these are increasing the hydraulic head of the water. So whatever water is coming from the bottom, it's going to come up again, it's going to go for the outlet, and then over here, the depth of the reactor may be up to this point. So what happens is, always, even if the water doesn't run, if the plant is stopped, at least 5 to 10 centimeter of the hydraulic head will be maintained, which we call it standing water, to maintain the life of the microbes. So same thing, the cross section, how we laid all the things over here, I'm showing it. Now, this is the constructional phase. The reason why I'm putting these photographs is to convince that this presentation is not all about just taking some biosand filter and treating it. It is about how we make it practically possible, not in a very large scale, but medium mid scale and very low cost. Why low cost? Because there will be no maintenance, there will be no operational cost at all. It is only the initial construction cost. So my staff are monitoring how to make it, because this is not actually in any textbook the way it's designed in a large scale of the biosand filter. So we are making a very cross finger check that nothing goes wrong even during the construction. And initially we have to collect the water through a syntax tank, water reservoir. Then in future we realized that it is not economical. The plant itself can treat consistently. So the quantity of the water itself depends on the reservoir that's going to be maintained. If the reservoir is huge, then the villagers can depend for 2 days. If the reservoir is just like say 1000 liters, then every alternate hours the plant has to run. So it is not like completely we read from a textbook and we have done the research. Laboratory skills also there, like optimizing the sand size particles, optimizing the depth of the reactors, optimizing the discharge so that we maintain proper biofilms. Now from this experiment itself, we realized that the syntax is not going to serve the purpose, so we start constructing a higher reservoir, which was not previously planned. Now, this is the actual picture. On the left side, you can see the pond that we have selected. This is in a place called Nambol in Imphal, Manipur. So this pond itself, we studied for a long time. We have a bargain with the villagers that this should not be contaminated, that they should also take the responsibility, because if we make it everything for free, then we realize that sometimes it goes wrong. People take it for granted. And then the value of this water treatment plant, the people of the villages where they have been deprived throughout their life, they're all generations with drinking water. When the ones they got it very easily, they may destroy it. It's just like a very spoiled son. So we have to make them responsible also. So it is not that once the water is treated, we integrate and we just make it very simple. You can see something written over here in Manipuri language. It is that if people are using here for say washing or cleaning, then they're going to pay fines. They shouldn't misuse the water. Some things are written by the club so that we take hand in hand responsibility. Then once it is over, it is not simply that we finish the work. It is also very important for us to monitor, because this is something to play with the health of the human beings, of the villages. We don't want to take everything for granted. So we monitor the treated water we monitor it for almost 6 months. Every alternate days with the treated water, we check all the physical parameters like the solids, the turbidity, and what you call the TDS, the conductivity, the pH, the chemical parameters, some of them like the iron, the nitrate, the phosphate, and then even the biological parameters we check with the pathogens, the coliforms, E. coli. Fine. So we have seen that the parameters are all almost zero, and some of them are within the permissible limits. So the turbidity is almost zero most of the time, and the coliforms. Okay. So with my BTech students, MTech students, PhD students, we keep on studying these things, and then the monitoring was done not only in the laboratory, it is done through survey mode also. Through the survey mode, we keep on discussing with the villagers, the health effect. We took the medical peoples, try to check regularly, showing them that we are much committed to the work, even towards their health, and then constant monitoring, especially with the children drinking this water continuously for the cooking or washing. So there was no something case like maybe vomiting or diarrhea, dysentery. So in fact, we can say that this water scientifically, even though it's proven, psychologically we treated them also, and the villagers happily accept with a big embrace for our water treatment plant. Now the next thing is, you can see that why I'm showing so many photographs, that this is not all about a fluke or just trying to download some Google pictures and these things. This we are sharing how we buy the ingenious technique, how we enhanced it through our engineering skills, and how we try to implement it and how we overcame so many things that is not in our textbook, rather than publishing in papers and conference for our promotions. So over here, what we've seen is, in order to run the plant, you can see on the left side, what we have seen is, we put some solar pumps over there, the solar plates, and then to run for a 1 horsepower motor pump. But in the days to come, so that the pump itself will just have to own it by the villagers. Since no electricity is consumed through purchasing the electric from the government, it is completely self-sustainable. No cleaning is done for the last 5 years. But something very unusual thing happens. That is, the pump was not able to run, and we observed that the battery is gone. Even the solar battery cell theft do occurs. These are the things we learn from the real fields. So finally, we also blame the villagers that they are not able to protect, but we don't blame them in such a way that they should not feel reprimanded. So that points, my research team is not about engineering. We have the humanities faculties also. Through their language, they discuss, they interact, the women faculties with the villagers who can convince them, so that we have a trust amongst ourselves. And finally, through the panchayats, we purchased even these water pumps, generator. Now, the petrol or the kerosene of the generator has to be borne by the villagers. Now, in fact, what I came across is the theft of the solar plate itself was a blessing in disguise, because the water has been misused by taking bath over there. Sometimes the other villagers, they bring large container, they connect the pipes through the nozzles, they pumped it out. So what happened is, once this generator has been purchased and done by the villagers, they get a responsibility because they have to pay the money. It is just like collecting 1 rupee every month from all the household. So the moment they pay 1 rupee or 2 rupee, they feel that it's their belongingness. So from here onwards, even proper looking after the pond water from the kettles, the responsibility of the club do increase. So I felt even the theft of the losing of the solar plate itself, even self-sustainable. It was a blessing in disguise. Now you can see on the right side how the water is clean. This is directly click on the spot itself. The water from the pond water itself was very clean. People already drank before, but now there is no smell, no contamination, no physical impurities. As simple as that, it's completely clean. The happiness about this thing is, even though we have come across a lot of advertisements in the TVs with ambassadors from the sports stars to the film stars, every reverse osmosis we purchase, we also pay them the money. My point is, do we really have to spend so much money over there? Because the water, simplest water, is the purest water, is the thing where all the parameters are below the permissible limit. Then when they say in the reverse osmosis advertisement, Sudhutani, Mitha Pani, do you think water should be sweet? The real water should not be sweet. So sometimes I joke to the villagers that if you want to sweet, in this bucket itself, drop an inch of sugar, then this will be Mitha Pani. So it's just a joking. So my concept is trying to remove all those illogical things. So you can see the villagers taking the water from here. And this reactor at the bottom, the top one is the first reactor I constructed. The second one is at the second place. This is very near to Manipur, where the Indian National Army Memorial is there. The Japanese Memorial is there. The place where the Japanese had a war in the World War II. Very near to that, near to the location, this is the water treatment plant. So the next is, how much, when I say the word low cost water treatment plant, let me see how much it is low cost. See, for the place like Manipur, the water bottle of 20 liters, it comes around 50 rupees, even though it may be 40 rupees in MRP, or it may be in say in the actual industry, we don't know. But the layman people pays almost 40 to 50 rupees per 20 liters for drinking water. And this plant cost around 7.54 lakhs. That is including all GST, the contractor fees, like their profit, including all the proper protocols of the government, how to construct it for the project. But if the villagers can build by themselves, it will be very less. So with this 7.54 lakhs of money, you can purchase 3 lakhs liters of water, right? So that means if we run this plant treating right 9,000 liters every day, it can treat it more. Even if we expect that 9,000 liters, which is the capacity of the reservoir we are maintaining in this place, even this much if we are doing it, and we are running it for the last 5 years without further treatment, this 7 lakhs can be recovered in 33 days. That means in complete 33 days, the amount of the water constructed over here is completely recovered. In case if you purchase from water bottles, that's my point. So it's completely free after 1 month. The second point is, even though not the exact drinking water, if it is a commercial water that comes in a like this magic van, it costs around 450 rupees in Manipur per 1,800 liters. Even though the tank is 2,000 liters, minimizing some of the bottom part, it comes around 450 rupees in 1,800 liters. So even if you calculate this can be recovered almost in 335 days. That is around 11 to 12 months. But the plan has been done for the last 12 months. And yes, the quality of the water that is going to be treated by this plant and that is brought by this commercial, it's completely hugely different. The water we treated can be completely drinkable, but this one still needs to be filtered. Another very simple example that I'm trying to convince the villagers is, the villagers, the panchayat himself, they were purchasing still the commercial water when we give awareness to the villagers. So my point is, it is very difficult to convince them psychologically. Say it is just like we can treat the urine to make it a drinkable water, removing all the impurities. But we will not drink. Why? Psychologically, we cannot accept. As simple as that. If you have a glass of water, you want to drink, you'll run for it. But if I said immediately, this water is inside this glass of glass for the last 4 days, means it's old, then immediately you will think a second thought whether I should drink or not. So this psychological impact itself is very difficult to remove. To prove that, I call all the villagers during the awareness camp and I drank directly from the treatment plant itself. So scientifically, we have already observed, and this commercial water itself, the turbidity, it comes around 4 to 5 NTU. Sometimes solid is around 10 to 20 milligram per liter. Even though it is within the permissible limit, my point is, the water that we treated at the low-cost treatment plant is much, much more pure than this commercial water. Okay. Now, next part is very important is, what I like to share my experience is the awareness to the villagers. Okay, so as I told you that the kettles and human intervention has to be prevented from the pond, not to take bath. If you want to take bath, take it out, water from it, and the club has to look after that very properly. The mechanism of the reactor was explained to the villagers properly. Else, what happened is they just think, put some sand, it'll be treated. No, we are making engineering skills, we are intervening it, we are intercepting it. We make the design, the depth, the grain size of the sand particles by saving it. At least more than 90% should be the desired size particle what we design. And do and don'ts, which are very wasting of water by the kids. So it should go hand in hand with what we fill it and what should be in the field with the villagers. Okay. So these are some of the, like presentations I give to the villagers to make them trust. And then on the left side, my staff are, like monitoring the water on the side itself. And then on the right side, it is the bottom part. At the beginning, we treated the water. At the beginning itself, before constructing completion itself, painting and all the things before it started itself, the village girls, very, very cute girl, they start collecting water for the drinking. And all the villagers listening to my monitoring. So this type of trust relation itself is also very important. So what I feel is, just by doing research in the lab, especially in the Northeast, making a lot of good publications, and especially that is accepted by the US and the European countries, why to get a promotions for a high impact factor, rather we are making a brain drain, but we forgot to implement it actually in our own field itself. So through this project, I like to open a one scope that not only about the promotion, about our own benefits, but it's very much peaceful and very much satisfied to these villagers who is getting free water, the purest water ever in their life in this village. This is my target. Okay. So you can see the smile on the woman's folk. They're carrying the water and they're bringing a very small lorry. The club restrict them to carry it by the vehicles, otherwise they'll misuse it, so that if they took the toil and hardship to carry the water this way, then they will use the water very economically and very wisely. Even this practice itself, we have never come across, in our textbook. So these are the experience I would like to share, and this is see how happiness we get when all these villagers are standing in a queue in a particular interval of time made by the club to collect the drinking water. In fact, we also got municipality water in my home, sometimes reverse osmosis, and then we treat it by the filter. But sometimes we forget to boil, sometimes we didn't boil it. But here itself, it is also completely pathogenic bacteria are completely killed by these biofilms. So the satisfaction to give this drinking water, the long-standing queue itself, looking itself, knowing that their burden is minimized to get the good drinking water without any cost. So with this water treatment plant that is completely low cost, I would like to thank all my listeners to at least enhance our skills, not only in paper and publications, but rather also to implement into our fields. With this, Dr. Alvino over here from NIT Manipur, I'd like to thank all my listeners and this Northeast Science Moment. Thank you.